Now we are taking one another question here. Okay. This is your another question. A right circular cylinder is placed with its center at the origin. And axis along positive x-axis along positive x-axis. Your question is calculate total flux through the cylinder okay, and
Yes, sir.
charge enclosed by the cylinder. All right, note it down,
Yes,
please.
sir.
Have you noted it?
Yes, sir. Yes, sir.
Okay. Now we have drawn a cylinder here. Okay. In this cylinder, it is saying that a right circular cylinder is placed with its center at its origin. I mean, the center of the cylinder is placed at the origin. Okay. Now, if you want to draw the coordinate system with respect to this origin, then you can look at here. This is your origin. Okay. This
Yes,
one
sir.
is the origin. All right.
Yes, sir.
This is your plus x-axis, which is given in your question. At its center, right cylinder is placed with its center at the origin and axis along positive x-axis. Okay. This is your plus x, this is your plus y, and this one is your plus z. Right. This is your point of origin here. Calculate the total flux passing through the cylinder and the charge enclosed by the cylinder. This is our question here. Okay. And now, if we try to see in this diagram, then can you tell me how many surfaces are existing here? I think there are total three surfaces.
Three surfaces.
This is your surface 1.
Yes, sir.
And this one is your surface 2. And this is your curved surface S3. Right? This is your curved surface S3. Now, another thing, according to the question, the center of the cylinder is placed at the origin. Okay. Then can you tell me what does it mean? It means we can consider that the electric field laying along the positive x-axis, I mean in this region, can be taken as positive, and which is given in your question is, one second, this is your positive x-axis and this one is your negative x-axis. So we can take here E is equal to E naught I cap, and the electric field along this direction is E is equal to E naught minus of I cap. Why we are taking here minus sign? Because it
So
is
because
lying
in
along
opposite
the
direction,
negative x-axis.
negative direction. Yes,
Yeah,
sir.
this is
Yes,
your
sir.
region of x is greater than 0, and we can consider this region as x is less than 0.
0 greater x less than 0.
Are you clear or not?
Yes, sir.
In this way, we can say that if we go to calculate the electric flux with respect to the cylinder, then what will be its calculation? This is your suppose that flux through S1 we are going to calculate. Okay, it is your phi 1 is equal to E dot S.
E dot S.
Right. And what is your E here for S1? E is your E naught minus
yes,
of I cap.
minus
And
I
what
cap.
is your area vector? Can you tell me? The area vector can be drawn for the surface S1 is perpendicular to the plane, which is always be along the positive negative x-axis, and for this it will be along perpendicular to the surface, and for this surface it is also perpendicular to the surface. Are you clear or not?
Yes, sir.
These are the area vectors. You can say here area vector. This is also area vector, and this is your also area vector. Now we can write here area vector is your, this surface is a circular surface, so we can take here it is a pi r square minus of I cap. After calculation you get E naught minus I cap and minus I cap after multiplication will be 1. So it is finally E naught pi r square, which is your phi 1. Are you understanding?
Yes, sir.
Similarly, flux through S2, right?
Yes,
It is
sir.
your phi 2. This is your phi 2. You can say phi 2 is your once again E dot S. E is your E naught I cap, and S is the pi r square I cap again. Finally, we get again E naught pi r square. Similarly, flux through chord surface. What is your chord surface? This is your S3, right?
Yes, yes, sir.
We can write here phi 3 is again E dot S, which is your E dot S is E dot S cos of 90 degree. We have already know, because the angle between the electric field you can look
Yes,
at
sir.
here. This is the direction of electric field, and this is the direction of the area vector. And finally, we get this is your 0. This is 0. Then
0.
what is the total flux? The total flux will be phi is equal to phi 1, phi 2, phi 3. What is your phi 1? This is your E naught pi r square.
E naught pi r square.
And another one is again E naught pi r
E
square.
naught pi r square.
This is 0.
Yes, sir.
Finally, we get the total flux is 2 E naught pi r square. Note it down, please.
Yes, sir.
Are you clearly understand this question?
Yes, sir.
Any issue?
No, sir.
All right. Note it down.
Done, sir.
Okay, good. Now we have calculated the total flux till now. Okay, but the
Yes, sir.
another part, the total charge enclosed by the cylinder is remaining now. Okay, now we are going to
Yes.
calculate the total charge enclosed by the cylinder. Okay,
Yes, sir.
total charge enclosed by the cylinder. We have already know the relation between the charge enclosed and the flux is phi is equal to Q enclosed over epsilon naught. So we can write here Q enclosed is equal to phi epsilon naught. What is your value of phi, which we have already calculated in the last page?
Sir, 2
E naught pi r square. Okay.
2 E naught
2 E naught pi
pi
r
r
square
pi r square.
epsilon. Are you clear?
Yes, sir.
This is your Q enclosed. Note it down, please.
Yes, sir. Done, sir.
All right, good. Next heading is application of Gauss law. Next one is application of Gauss law. What is the application of Gauss law? We have already know the formula of the Gauss law from the last lecture. You can write here calculation of electric field due to symmetrical charge distribution integration of E dot ds is equal to Q over epsilon naught. All right. And the next point, what are the conditions or main conditions or criteria of the Gaussian surface? So please note it down, the Gaussian surface. Okay. In this, we will understand how can we choose a Gaussian surface. Okay. This is your Gaussian surface. And what are the criteria of the Gaussian surface? You can also say criteria of Gaussian surface. Can you tell me what are the criteria of the Gaussian surface? Have you already studied or not? The first criteria is Gaussian surface should be closed. All right. Which is your E dot ds is equal to Q over epsilon naught. E dot ds is equal to Q over epsilon naught. This is your formula of the Gaussian surface. But remember that Gaussian surface should be closed. I mean, like this, it is possible like this. It is also possible like this. I mean, in the cylindrical form also you can take. All right or not? But the main condition is that the Gaussian surface should be closed. It never be open. If your surface is open, then it never satisfies the Gauss law. All right or not? Similarly, in the next point, your electric field is either parallel. Electric field should be either parallel or perpendicular to area vector, which is when the electric field is parallel, when E is parallel to the area vector, then your theta will be 0 degree. If theta is equal to 0, then your formula will be E dot ds cos of 0. Finally, you get E ds cos of 0 degree is equal to Q over epsilon naught. And when E is perpendicular to S, in this case, theta will be 90 degree. Then your formula will be E ds cos of 90, which is finally equal to the 0. Why? Because we have already know cos 90 is 0. Are you understand or not?
Sir, can you explain again? I was disconnected.
When you was disconnected?
Sir, in Gaussian surface explanation, I was disconnected the whole time.
Okay. No issue. In this heading, we are trying to understand what are the criteria of the Gaussian surface. Are you clear? I mean, how can we choose the how can we choose a Gaussian surface? In the first point, it is saying that Gaussian surface should be closed, right?
Yes, sir.
Okay,
yes, sir.
I mean closed in the sense it never be open. Just like if you are choosing just like a Gaussian surface, then it is wrong. But if you are choosing like this Gaussian surface, then it is correct. Okay, because this is
sir.
a closed surface. Are you clear or not?
Yes, sir.
So
Yes,
remember
sir.
that it doesn't matter what is the configuration, or you can say what is the shape and size of the Gaussian surface, but okay, it matters it is open or not. Are you clear?
Yes, sir.
Okay, because we have already know Gaussian. Okay, Gauss law. Yeah, there is no any particular type of shape. Okay, it describes. Are you clear?
Yes, sir.
It may be any of the surface. Are you clear? Any type
Yes,
of the
sir.
surface you can take as a Gaussian surface, but the one of the most condition is important condition is that it should be closed. Are you clear or not? It
Yes,
doesn't
sir.
matter what is the shape of the Gaussian surface. Okay, it may be defined shape or okay non-defined shape. Such like if you are taking like this shape, then it is a defined shape. But if you are taking like this shape, this is not a defined shape. Are you clear or not? But this shape may also
Okay,
be
sir.
a Gaussian surface. Are you clear?
Yes, sir.
Yeah. In the second point, it is saying that electric field, Gaussian surface either be for any Gaussian surface, electric field either be parallel or perpendicular to the area vector. Okay. For any Gaussian surface, electric
Yes,
field
sir.
is either parallel or perpendicular to the area vector. Okay. When electric field is parallel to the area vector, then theta will be 0 degree. Then we can write this equation E dot ds cos 0 degree, which is equal to the q over epsilon naught. And when it is perpendicular to the area vector, then you can write theta is 90 and E ds cos 90, which is equal to 0. Okay.
Yes, sir.
Now, the next point is point number 3. Point number 3. Point number 3 is telling us that E should be, E in the sense electric field, should be uniform throughout Gaussian surface.
Okay, sir.
Okay. Electric field should be uniform throughout the Gaussian surface. This is a E integration of integration of ds, which is equal to q over epsilon naught. Again, this formula is true. Okay, note it down, please.
Yes, sir. Done, sir.
Okay, good. Next one is types of Gaussian surface. Remember that there are different many type of Gaussian surface you can choose, or you can say Gaussian surface you can choose according to your own convenience. Okay, but
Yes, sir.
we are discussing here about the type of Gaussian surface which are mostly used in our syllabus. Okay. Types of Gaussian surface. Types of Gaussian surface. The first one is of spherical. Second one is cylindrical. And the third one is cuboid. Cuboid in the sense, which is also known as Gaussian pillbox. Note it down.
Yes, sir.
These are three main, three type of Gaussian surface which are mainly used. Okay.
Yes, sir. Yes, sir.
Yeah.
Done, sir.
All right. Next heading is electric field. Due to infinite line charge, or you can say wire, or you can also say rod. Suppose that we are taking a sorry, just 1 second, please. We
Yes,
are
sir.
going to discuss first charge density. Okay.
Yes, sir.
Charge densities. Give me a second, please.
Sir,
Yeah.
actually on 22nd, I have my unit test of physics.
22nd. Okay.
June.
22nd June. I mean, in this month.
Yes, sir.
Okay. And what is the syllabus?
Sir, the first chapter, electrical field, and the second, electrical capacitance.
Electrical potential.
Yeah, potential and capacitance.
Potential and
Yes.
capacitance. Today we are in this part. 1 second. I am just seeing you. Give me 1 minute on this. In the next class, your
Yes, sir.
chapter 1 will over.
Chapter 1 is over. Okay.
Yeah. Okay.
Okay, sir.
And from the next class, we will start electric potential.
Okay, sir. So next week.
Yeah.
Okay.
Yeah. Next one is charge densities. Charge densities. What are the charge densities here? Remember that charge densities are of three types mainly. The first one is linear charge density. Okay.
Yes, sir.
Linear charge density, or sometimes it is also called linear charge distribution. All right.
Yes, sir.
When the charge density are said to be the linear charge density, it is said to be the linear charge density when charge is distributed. Charge is distributed in one-dimensional body. Are you clear?
Yes, sir. And it
For
has a
definition?
unit of coulomb per meter, right?
Yeah, you can also write coulomb per meter. Okay.
Yes, sir.
When you want to define it, then you can say the charge per unit length.
Yes, sir.
It is a charge per unit length. This is your definition. You can write here lambda is equal to Q over L. It can be used for uniform charge distribution. All right.
Yes,
and
sir.
then you can also write lambda is equal to dq over dl. It can be used for uniform and non-uniform both. Uniform and non-uniform. Okay, charge distribution.
Yes, sir.
Next one is surface charge distribution. Surface charge distribution, or you can also say surface charge density also, which is denoted by sigma. The definition is charge per unit area. Okay.
Yes, sir.
Charge
Unit
per
is coulomb
area.
per meter square.
I mean, sigma is equal to Q over
Yes,
S, where S is your area vector. Okay. This
yes, sir.
formula is used for uniform only. You can also write sigma is equal to dq over ds. This is used for uniform and non-uniform distribution or field. Note it down. The third one is volume charge density. Volume charge density. It can be defined as charge per unit volume. It is denoted by rho. Rho is your Q over V. V in the sense volume.
Yes,
This
sir.
is used for uniform, and similarly we can also write dq over dv, which is used for uniform and non-uniform. Note it down, please. What are the unit here? Your unit will be coulomb per
meter.
Unit of
Coulomb
this
per
is your
meter square.
coulomb per meter square, and for it this is your
Coulomb per meter cube.
Note it down. Okay.
Yes, sir. Sir,
Yeah.
in the charge, volume charge density, what is our sign, sir?
Sorry.
What is the sign, sir? Is equal to Q by V. What is that?
dq or dv?
No, the upper one, sir. Upper one. What is equal to Q by V?
This is your rho. R
Rho,
H
right? Rho, right? Yeah, yeah.
O.
Okay.
Rho.
Rho. Done, sir.
Okay. And now, next one is electric field due to infinite line. Charge or wire or rod. This is our next heading. Okay.
Yes, sir.
In this, we are taking a rod like this, and we are going to calculate, sorry, some amount of charge is distributed upon this rod. These are the amount of charges which are distributed upon this rod. Okay. It is saying that it is saying that calculate the electric field due to this infinite line charge. Okay. In what amount electric field is generated here. So to calculate the electric field, we are going to choose first Gaussian surface for this. And we are choosing here Gaussian, we should choose the Gaussian surface in such a way that it should be symmetrical to the body. If it is symmetrical to the body, then it will be easy to calculate the electric field. Okay. We are taking here a Gaussian surface in cylindrical of shape. You can take it like this. This is of cylindrical in shape. And we can write here the radius is R. I mean, the radius of the cylinder is R. And now, can you tell me how many surfaces are available here? I think there are total 3 surfaces.
Three surfaces. Three surfaces.
This is your surface 1. This one is your surface 2. And this one is just surface number 3. Due to this positive charge, electric field lines will go away from the charge body. I mean, along this direction. Are you understand or not?
Yes, sir.
It will be along this direction. Okay. But what will be the area vector? The area vector for surface 1 can be taken as perpendicular to the surface, which is along this direction. For this, it is also perpendicular to the surface. And for this, it is also perpendicular to the surface. These are makes 90-degree angle from the surface, or you can say this is also makes your area vector, which are making 90-degree from the electric field lines. Are you clear or not? But
Yes,
your
sir.
surface 3 is not making 90-degree, it is making 0-degree angle. Are you clear or not?
Yes, sir.
Yeah. Once again, we are going to do the same things As previous we have did in the last question. What is a flux? Flux through end one, or you can say flux through S1. What is your S1? It is your
Surface.
phi 1.
Yes.
We can write here phi 1 is equal to E dot S, which is ES cos of 90 degree. Am I right or not?
Yes, sir.
Finally, we get 0. Similarly, flux through end S2. Again, we are going to do the same things. ES cos of 90, which is again 0. And the last surface is flux through chord surface. This chord surface is your surface number 3.
Yes, sir.
This is your phi 3 is ES cos of 0 degree, which is your E and S. What is the electric field? Electric field line passing through it. This is this can be taken as 1 second. E dot S. 1 second. Take it integral because it is for the infinite. This is of infinite line charge. Okay. So E dot S. We get E, and S is your 2 pi RL. All right or not?
Yes, sir.
What is the total flux?
Phi 1 plus phi 2 plus phi 3.
What is the total flux?
Phi is equal to
Phi 1
plus phi 2 plus phi 3.
phi 3. We get 0 plus 0 plus E into 2 pi RL. Finally, we can say phi is equal to E into 2 pi RL. Are you clear till here?
Yes, sir. Yes, sir.
This is the total flux passing through here. And now again, next question. If anyone asks you what is the electric field, we are going to calculate the electric field here. First of all, we have calculated till now the electric flux passing through this Gaussian surface. Now, what is the relation between the field and the flux? We know phi is equal to Q enclosed over epsilon naught. What is the value of phi? Phi is your E into pi RL is equal to Q enclosed over
Q
epsilon.
enclosed by epsilon 0.
What is the Q? This is your line charge density. Then we can write
Yes,
here
sir.
lambda is equal to Q over L. 1 second. Write down here. We know Q is equal, lambda is equal to Q over L, or Q enclosed is equal to lambda into L. Put this value in this equation. You get E into 2 pi RL is equal to lambda into L over epsilon naught. L is cancelled with L. Finally, E is equal to lambda over 2 pi epsilon naught R. This is the amount of field produced by this line charge. Are you clear?
Yes, sir.
From this equation, you can also notice here that your E is lambda over 2 pi epsilon naught R. From this equation, we can also see E is inversely proportional to the R. If E is inversely proportional to the R, then what will be the graph here? The graph will be like this. Okay.
Yes, sir.
This will be the graph. All right. This axis can be taken as R, and this one is taken as E. Note it down, please. This is over. This heading is over.
Okay.
Done.
Done, sir.
Okay. Next heading. Sorry. Next question. In this question, infinite line charge is given. Two infinite line charge is given. And there is a point at the center of these two infinite line charge, O. Okay. One of the charge
Yes,
is positively charged, and the another one is negatively charged. The separation between these two is 2A. Separation between these two line charge is 2A. Then easily we can say the separation from center of each line charge is A. Are you clear or not?
yes, sir.
This is A and this one is also A. The density of the charge on the positive line is lambda1, and for second one is lambda2. According to the question, calculate electric field at O. This is your question. Calculate electric field at O.
Okay.
Can you solve it?
So one more I'll try.
All right. And just I am coming in 2 minutes. Okay.
Yes, sir. Yes, sir.
Can you solve it, Harsh?
So 1 minute, 1 minute.
Okay.
Sir, can you solve it? I'm getting a little bit confused.
Okay. And now, what is the direction of the field at point O due to positive charge line?
So
It
can you
is,
repeat?
what is the direction of the electric field due to a positive line charge? It always be away from the positive charge, am I right?
Charges. Yes, sir. Away. Outwards.
Similarly, what will be the direction of field due to negative?
Inwards.
It is towards the charge. I mean,
Yes,
we
sir.
can say this is your E plus and this is your E minus. Both are existing in the same direction. So we can write here the net field at O, which is your E is equal to E plus of E minus. Okay. Once again, we write what is your E plus. We have already know due to the line charge, the formula equation is this. Okay. Lambda over
Yes, sir.
2 by epsilon naught R. So it is your lambda 1 over 2 pi
2 pi
epsilon naught R.
epsilon 0 R.
What is your direction? Direction is along plus x-axis. So we can take here I cap
I cap.
plus lambda 2 over 2 pi epsilon naught
R
R
on 0 R.
I cap.
I cap.
Again, E is equal to we can take as common like I cap over 2 pi epsilon naught R. In
0.
bracket,
So
it is
lambda 1
1
plus lambda 2.
plus lambda 2. Okay. Are you understand or not?
Yes, sir.
Yeah. This is your final answer.
Yes, sir. Yes, sir.
Note it down, please.
Huh?
Note it down. This is your
Only
final
this
answer.
much. Done, sir.
All right. Okay.
Sir,
Yeah.
in the electric field, E is equal to lambda plus 2 pi. Sir, it doesn't minus I cap should come in the lambda to 1 because it's in the opposite direction, right?
No, 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 no. If you are taking, suppose that you are taking a coordinate system, okay, then can you tell me what will be the direction of E plus and E minus? Both are along plus x,
X-axis.
plus x, not minus x.
Yes, sir. Yes, plus x, sorry, plus x.
Yeah, yeah. So we are taking here plus I for both lambda 1 and lambda 2.
Okay.
Okay.
Okay, sir.
In any case, suppose that we are taking here once again positive charge for this. Suppose that we are taking here
Sir, you're
positive charge.
lagging.
In that case, the direction for the second one is along this direction. Are you clear or not? Now you should choose
Sir,
your E plus
sir,
plus of E minus I cap, and it will be minus of I cap. And finally, this minus sign, when multiply with this plus, you get minus here. Are you understand or not? Hello?
Yes, sir. Yes, sir.
Yeah. Okay. Now, the next one is.
So 1 minute, my internet is lagging. So 1 minute, so 1 minute.
Okay.
Yes, sir, you can continue.
Now, electric field due to infinite plane sheet. This is the next heading. This one is next heading, which we are going to study now. Electric field due to infinite plane sheet. Okay.
Yes, sir.
We are taking here an infinite plane sheet of charge. This is your infinite plane sheet of charge. Okay. This is your infinite. Okay.
Yes, sir.
It is saying that what is the electric field due to this infinite plane sheet of charge? First of all, we should consider a Gaussian surface, which is cylindrical in shape. Okay. Consider a Gaussian surface. Sorry. Consider a cylindrical Gaussian surface. Mention here cylindrical. Okay.
Yes, sir.
Cylindrical Gaussian surface having area of ends S. We are taking here this is your Gaussian surface which we are taking.
Yes, sir.
And the area of this plane sheet is your S. So this cross-sectional area also be S. The unit vector always along the perpendicular to the surface, or you can say this is your area vector again. Electric field lines is this. These are the electric field lines which are passing from this surface. Are you clear or not?
Yes.
Okay. Now, how many surfaces are there? This is your surface 1. This is your
2,
surface 2. And this
3.
one is your surface number 3. Again, we are going to do the same things as we have already did in the last some
Yes.
questions. Okay. Flux through end 1, which is your phi 1 is E dot S, which is ES cos 0. Am I right or not?
Yes, sir.
Okay, 1 second. ES cos 0 you can take here at once. Finally, we get ES. Similarly, flux through end 2. This is your phi 2 is ES cos of 0 again. You get ES. Again, flux through curved surface, right?
Yes, sir.
Flux through curved surface. Your curved surface is your surface number 3.
Yes, sir.
No need to write here. This is your phi 3 is ES cos of 90. It will be 0. I understand.
Yes.
What your unit vector? Area vector. Your area vector always be perpendicular to the surface. And you can look at electric field and the area vector are making 90 degree. So when you take cos 90, it will be 0. Okay.
Okay. Yes, sir.
Now, total flux. What is your total flux? Total flux is phi.
Total flux, phi is equal to phi 1 plus phi 2 plus phi 3.
Phi 3. Phi 1 and phi 2 is ES plus 0.
ES plus 0.
Finally, you get 2 ES.
2 ES.
Phi is equal to.
Yes, sir.
Okay.
Yes, sir.
Note it down, please. Phi
Yes,
is
sir.
equal to 2 ES. 1 second. Till now, we have calculated the flux. Are you clear?
Yes, sir.
And now it is saying that electric field. What will be the electric field? Once again, I am writing the same equation. Phi is equal to 2 into S, 2 ES. And now, relation between the electric field and phi is equal to, what is the relation? Which type of charge densities are available on this surface? It is your surface charge density.
Yes, surface charge density.
Right here.
So it will be, yes.
Sigma is equal to Q enclosed over S.
Sigma is equal to Q by S.
Q enclosed over S.
Yes, sir.
1 second.
So delta dQ by ds.
Please, 1 second.
Okay.
Phi is equal to, we have already know the relation between the flux and charge is phi is equal to Q enclosed over epsilon naught. When you put the value of phi here, it will be 2 ES is equal to Q enclosed over epsilon naught. What is your Q enclosed? This is your
Q enclosed
is equal to sigma into S. Okay?
Yes, sir.
When you put this value here, you get 2 ES is equal to sigma S over epsilon naught. S is cancelled with S. E is equal to sigma over 2 epsilon naught. Note it down.
Yes, sir.
I think application of Gauss Law is very easy.
Yes, sir. Yes, sir.
Am I right?
Yes, sir.
It is very, very easy calculation. Most of the questions and the derivation are on the same pattern. Okay.
Yes, sir. There's a derivation on the side, cylindrical surface.
Yeah.
Done, sir.
Okay.
Yes, sir.
Oh, remember this equation here.
Yes.
E is equal to sigma over 2 epsilon naught, right?
Yes, sir.
Sigma over 2 epsilon naught. You can observe this equation. This is independent on R. I mean, it doesn't depend on the position. Are you clear or not?
Yes, sir.
Independent of R. And so we can also say this is like of uniform field. Okay. If the field is uniform, then what will be the diagram between the E and R? As we
Parallel.
can look at here, the electric field is not depending upon the R here. So we can draw a parallel line.
Yes,
We
sir.
can draw a parallel line. And it represents electric field is independent on R. Note
Yes.
it down, please. Have you noted
Done,
it?
sir. Yes, sir.
Good. We are taking a question now. Our question is, there are two infinite plane sheet of charge. Okay.
Yes,
These
sir.
are the two field lines, two plane sheets in which there are total 3 regions. This is your region 1. This one is your region 2. And this is your region 3. Are you understand?
Yes, sir.
Yeah. It is saying that calculate electric field in region 1, 2, and 3. region 1, in region 1, region 2, and region 3.
3.
This is our question. Okay.
Yes, sir.
This sheet having charge of plus positive nature, and this is your negatively charged. And now, first of all, we are going to draw, 1 second, the density is sigma 1 and this is your of density sigma 2. Okay. Now, first of all, we are going to draw for sigma 1, I mean field lines for sigma 1. Can you tell me what will be the direction of the field lines for the sigma 1 in region 1? It is towards or away?
Outward.
Outward. I mean, it is your away direction. Okay.
Yes, sir, away. Sorry, away. Yes.
Away. This is your away direction. And in region 2, what will be the direction due to sigma 1?
Inwards, sir, inwards. In the
direction. In which direction? Plus x or minus x?
Sir?
What will be the direction of the
sir, plus x.
Plus x, exactly.
Plus X.
Good. And in region 3?
Region
again in plus x.
Plus x.
Right?
Yes.
This is the direction of the field. We can put it here E1, E1 and E1. Okay?
Sir, in region 3, shouldn't it be in
no.
Minus x because the negative charges?
No. Just listen me first. When you are drawing for any one of the sheet, then you don't mind what is the is there any other sheet is available or not? Are you clear or not?
Yes, sir.
Yeah. We are trying to draw electric field lines due to only and only positive sheets. Okay. So we are not considering here there is any other sheet.
Yes, sir.
Okay. And now we are coming on the sheet number 2. I mean sigma 2. What will be the direction in the sigma 2? For sigma 2 in region 3.
Sir, plus x, right?
In region 3, what is the direction of the electric field lines for sigma 2? I mean for negative charge plate. It is always towards.
No, yeah, negative to negative x-axis. Yes.
Okay.
Yes, sir.
In region 2, what is the direction due to sigma 2?
Sigma 2, sir, towards sir, positive x-axis.
Positive x-axis. Good. Again, in region 1.
Negative x-axis.
No. Positive x-axis. It is also towards the positive charge.
Towards positive.
Towards negative charge plate.
Okay, yes.
Are you understand?
Yes, sir.
This is your E2, E2 and E2. Are you clear?
Okay. Yes, sir.
And now your calculation is very, very easy. Okay. We have equation due to plane sheet of charge E is equal to sigma over 2 epsilon naught. Remember this equation. Okay. In
yes,
region
sir.
1. In region 1, your E will be E1 plus of E2. What is your E1 for region 1? E1 is your sigma over 2 epsilon naught. What is the direction of E1?
E1 was out.
Minus I cap.
Minus I cap, yes, sir. Negative
plus E2?
Sir, sigma by 2 pi.
Sigma 2 by 2 epsilon
sigma 2
naught.
by 2 pi epsilon 0.
Okay.
I cap.
I cap plus. Okay.
Yes, sir. Plus I cap.
And what is the final value? It is your I cap over 2 epsilon naught in bracket minus of sigma 1 plus of sigma 2. Are you understand?
Yes, sir.
Similarly, we are coming on region 2. So, one second. So, we can write again for region first, it is your I cap over 2 epsilon naught sigma 2 minus sigma 1. This is your electric field in region 1. Similarly, in region 2, this is your E of 2, which is your E1 plus E2. What is your E1 in region 2?
Sir, E1 in region 2.
Yeah.
Sir,
Sigma 1 over 2 epsilon
sigma 1
naught.
by 2 epsilon naught 0 plus
okay.
I cap.
I cap plus. Okay.
Yes, sir.
Second one, sigma 2 over 2 epsilon naught I cap.
Plus I cap.
Okay. Hence,
Yes,
we
sir.
can say I cap over 2 epsilon naught sigma 1 plus sigma 2.
Yes, sir.
Are you understand?
Yes, sir.
Note it down, please.
Done, sir.
Good. And now for region 3.
Sir, will we add this up for region 3?
Sorry. No, there is no need to add all of the
Will we
here.
add this up?
Yeah, because it is asking in individually. Okay, in region 1, region 2, and region 3.
Okay.
So it is your
Okay,
E3, and E3 is equal to E1 plus E2. What is your E1? E1 is again
E1
sigma
is
1 over 2 epsilon naught.
sigma
Direction
3
is
2 epsilon
I cap
plus I cap.
sigma 2
Sigma 2 by 2
epsilon naught
epsilon
minus
0
of I cap. Finally,
minus
you get
I cap.
I cap over 2 epsilon naught. This is your sigma 1 minus sigma 2. This one is your E3.
Yes, sir.
Note it down, please.
Done, sir. Sir?
Yeah, hello.
Yes, sir. Done.
Okay. Done. So
Yes,
today
sir.
we are going to over this class now because
Okay.
the next point is a long point. I mean, very, very long
Okay.
point. And
Okay,
we will
sir.
continue it in the next class. All right.
Okay, sir.
I think your concept is clear for the in today's